Good afternoon, all of you. In the previous class, we discussed about reversible and irreversible processes with respect to expansion and compression. And today we will be discussing about isothermal free expansion. So you all are familiar with isothermal processes and expansion. So now we will see what a free expansion means. So the same apparatus which we know, the cylinder with a piston in it. Here exist two types of pressures, which are the internal pressure due to the collision of gas particles and the external pressure, which is the atmospheric pressure. So when the atmospheric pressure or external pressure becomes more, then obviously compression will be the product. Compression will occur when the external pressure is more. And when the internal pressure becomes more, then elongation or expansion occurs in the same case. So when external pressure is more, compression occur, and when internal pressure is more, then the expansion occur. But there is a case where there is no external pressure when we have vacuum around this container. When there is vacuum around the container, or we can tell there is absolutely nothing, there is no molecules present outside the container. In that case, there is no molecules at all. So who will exert the pressure? Nobody. So when there is vacuum around the container, there is no external pressure at all. So when Px or the external pressure becomes 0, there what happens is expansion. Because there is pressure inside the container, and when there is zero pressure outside the container, then the internal pressure becomes more, and this will cause expansion. This kind of expansion where there is no external pressure is present, these are known as free expansion. So expansion of gas in vacuum, or when there is absolutely nothing around the container, that kind of expansion is known as free expansion, or the expansion when Px is equal to 0. No work is done during free expansion of ideal gas, whether the process is reversible or irreversible. Because we know the equation for work done. One equation for the irreversible process tells us work is equal to P external into delta V, and in reversible process it is integral P external into dV. In both the cases we have P external as a factor. So when P external is 0, both the equations become 0, so we can tell no work will be done during free expansion, even if it is a reversible process or an irreversible process. So now you know what is a free expansion. Moving on to the next step. So this is the equation for our change in internal energy, which is the first law of thermodynamic equation. Delta U is equal to Q plus W. In this equation, we are going to change it a bit by applying one equation of work into this. So work is equal to minus of P external into delta V. This is an equation for work done in an irreversible process. This we are going to substitute in this equation. Hence we get it as, so delta U is equal to Q minus Px into delta V. So in place of work, we substituted this value. Hence we got it as delta U is equal to Q minus Px into delta V. And we are not going to keep this delta V a constant. So change in volume when it becomes 0. So the initial volume is equal to final volume, delta V will be equal to 0. That we are going to do in this equation. So if this equation, and if the process is carried out at constant volume, then the change in volume or delta V will be equal to 0. So initial volume and final volume, if it is same, then we get delta V is equal to 0. So if we change, or if we apply this change to this equation, hence what it will become? So delta V is equal to 0. So the product of Px and delta V is also will be equal to 0, right? So Px into delta V will be equal to 0. Hence the delta U term will only depend on the Q. or the change in heat. So delta U when the volume is constant will become delta U is equal to QV as this term became 0. So what is V represent, which is the constant volume. So when volume is constant, then the change in internal energy will be equal to QV. So keep this equation in mind. So now we are moving on to the real discussion, which is about the isothermal and free expansion of ideal gas. So free expansion, you know what it is, and I hope you all are clear with what is an isothermal process. There is tendency in between people to confuse between isothermal and adiabatic processes. So first we will compare isothermal process and an adiabatic process. First we will tell about the isothermal process. So in an isothermal process, what happens is we keep our temperature always constant, or initial temperature and final temperature should be same. It does not mean that there is no heat exchange. It can exchange heat with the surrounding. For example, when the temperature of this system increases to a particular temperature, what we will do? We want to keep the temperature low. So hence we will add some ice to it. So slowly the temperature will again decrease. So like this also we can keep our temperature a constant one. The only thing is that initial temperature and final temperature should be same so that the delta T should be 0. That is the only condition for isothermal process. So what is that? Initial and final temperature should be 0, but the delta Q or the heat exchange should not be 0. It can vary because we can supply heat or we can take out heat. Whatever we do, the initial temperature and final temperature should be same so that the temperature difference should be 0. This is the case of an isothermal process. In case of adiabatic process, how it will be? We get adiabatic process in an adiabatic wall. So here there is no exchange of heat energy between this. So delta Q will be 0 because there is no exchange of heat between system and surrounding. But can we tell that delta T will be equal to 0? It cannot be, because if we do work inside the system, for example, we have done work inside an adiabatic system for the previous experiment. We have put a pulley inside the system and we rotated it. So the temperature also increased. I hope you remember that experiment which we have done. So we can have methods so that we can increase the temperature, or difference in temperature is possible. But in adiabatic system, Q will be equal to 0 or delta Q will be equal to 0, but T may not be equal to 0 as we can do work inside the system. So this is the difference between an adiabatic and isothermal process. In an isothermal process, delta T was equal to 0 and delta Q was not equal to 0. Just the opposite we have in the adiabatic process. We have delta T may not be equal to 0, but delta Q will be equal to 0 as there is no exchange of heat energy. So remembering all these facts, we are moving on. So we are doing an isothermal and free expansion, which tells us that there is no external pressure, or P external is equal to 0, and even it is isothermal where we have delta T is equal to 0. And in this case, experimentally we are doing delta Q is equal to 0, or delta Q is also kept constant. So for isothermal, T is equal to constant, expansion of ideal gas into vacuum. So P external is equal to 0. When P external is equal to 0, work also becomes 0. So experimentally, when Q is equal to 0, from this equation we are doing delta U is equal to Q. Just now we got it. So that when we substitute, delta U is also becomes 0. Internal energy change is also 0. So these are the conditions what we have. So write all these conditions as we move on. So that will give you a better understanding. So we are going to substitute those conditions into this equation. So delta U is equal to Q plus W can be expressed for isothermal, irreversible and reversible change as three conditions. So the first condition is for isothermal irreversible change, Q is equal to dash. So that is our question or condition. So in delta U is equal to Q plus W, we are going to apply these conditions. In an isothermal reversible process, how it will be? We told that delta U is equal to 0. Hence, Q plus W is equal to 0. If Q plus W is equal to 0, what will be the value of Q? So W will come this side, hence the sign will become negative. Q is equal to minus of W. So here Q is equal to minus of W we get. So what is the value of minus W? We have isothermal and irreversible process. For an irreversible process, what will be W? W is equal to negative Px into delta V or Px into V final minus V initial. This we are substituting here. So W is equal to minus of this value. Hence minus W will be equal to positive of the same value. W was equal to minus of P external into delta V. So minus of W is equal to P external into delta V. That is the first condition. And for the second condition, we have for isothermal reversible change. As it is isothermal and we have delta Q is equal to 0, hence Q is equal to negative W, same which we have done in the earlier step. So what will be the value of negative W in reversible change? Reversible change, we have found out an equation which is nRT ln Vf by Vi. The same equation we substituted in log, which was 2.303 nRT log Vf by Vi. So the value of W was negative of nRT ln Vf by Vi. As we have negative W which is asked, so we have positive of nRT ln Vf by Vi. So the same equation we have substituted with log, which was 2.303 nRT log Vf by Vi. So this is an equation for isothermal reversible change. So next is for adiabatic change, Q is equal to 0. We have discussed it earlier. So for an adiabatic change, there is adiabatic wall present. So when adiabatic wall is present, there is no exchange of heat. So hence it will become Q is equal to 0. When in this equation Q is equal to 0 means delta U is equal to W. So delta U is equal to W adiabatic. So that is the equation here. And we completed the three conditions for isothermal free expansion. With this understanding, if you read the textbook, you will get a clear idea. So please read the textbook and prepare notes. Thank you.